Gaza will need to be rebuilt, and the south of Lebanon will need to be rebuilt, and the southern suburbs of Beirut.
9 of the 10 slices of pizza have already been eaten, and now we want to divide up that last piece.
Yes.
And those who ate the 9 want to say, forget the fact that we ate those 9 already.
Greenwashing is rife in the industry. So.
Welcome to The Merge. I'm Alan Shihadeh, Professor and Dean of the Faculty of Engineering and Architecture at the American University of Beirut. On this podcast, we speak with thinkers and doers whose work crosses disciplinary boundaries and challenges conventions. Today, we're lucky to have with us Dr. Majd Helal. Majd is a visiting faculty member in the Department of Civil and Environmental Engineering at AUB and is the Assistant Dean for Sustainability at the University of Melbourne School of Design. His award-winning research looks at how the total embodied carbon of buildings relates to how they are designed. His current focus is developing software tools and computer models that enable the automation and integration of embodied carbon assessment into the early-stage structural design of buildings. Majd, welcome to The Merge.
Thank you for having me.
Majd, most of us think about buildings as energy users once they're running. The heating, the cooling, the lighting, but your work starts with a very different question. What if the biggest climate cost of a building comes before anyone ever moves in? Can you explain why that shift in thinking matters so much and what we're missing when we're only focusing on operational energy?
Sure. So traditionally, efforts to improve the environmental performance of buildings have mainly focused on the operation of buildings, so on heating, cooling, lighting, ventilation. So whenever you hear about a sustainable building in the past, that was its focus. But today there's a growing understanding and appreciation about the importance of embodied carbon. So those are the greenhouse gas emissions associated with the manufacturing of the materials we use in our buildings. And the research shows that the embodied carbon represents the vast majority of the total life cycle greenhouse gas emissions of buildings, especially when you think about the decarbonizing rate of our electricity and energy systems into the future. Over time, buildings will become more environmentally friendly and less carbon intensive because our electricity is becoming less carbon intensive, which means that the materials we use today are more and more important. And we really need to think about where are these materials coming from and how we are manufacturing them as part of a change in the way that we think about buildings and design them so that it goes from cradle to grave and not just designing them and handing it over to the building user.
So if we look at buildings today, the building stock today, even with those buildings, would you say that the embodied carbon is a major contributor to the total equivalent emissions of those buildings?
Yes, very significant, especially when you consider the temporal nature of greenhouse gas emissions, that these emissions are occurring today, which means that their impact in the climate will last for thousands of years. Whereas when it comes to the operation of buildings, hopefully over 50 to 100 years, those are emissions that will occur in the future. By then, we hope, and we're working towards again, decarbonizing the operation of buildings, but the decisions we take today have lasting climate effects for generations to come. So we are more in control of these emissions, besides them being more significant as a total proportion of life cycle greenhouse gas emissions.
So again, we're combining two different things. We're talking about embodied carbon and we're talking about greenhouse gas emissions. Maybe we can clarify this a little bit in its connection to climate. You had a paper recently in the Journal of Cleaner Production. It was in 2024, and it starts by pointing out that the building sector is responsible for over a third of global greenhouse gas emissions, and that's expected to rise. Most of us think of buildings as passive objects. Why do they have such a big climate impact?
Sure. The built environment is incredibly resource and energy hungry. It uses most of the world's production of cement. Practically all of the cement is used by buildings and infrastructure. It uses 50% of the global supply of steel, 25% of aluminium, 25% of plastics. And it alone is responsible for about 40% of global energy use, and therefore 40% of our greenhouse gas emissions related to energy use. So if we want to address the climate crisis, buildings have to be a part of that conversation. And really, if you think about it, the reason why the scale of its contribution is so large is because we spent so much time in buildings. About 90% of our time as humans on average globally is spent indoors, which is quite a shocking and sad statistic if you think about it. And so because we're spending so much time indoors, we rely on our built environment. We spent a lot of resources to construct and operate them. So again, buildings are responsible for 40% of the global greenhouse gas
And
emissions.
when we say they're responsible for 40%, are we talking about the embodied emissions, or are we talking about both the embodied and operating?
Both.
Okay.
The manufacturing of cement and steel alone is responsible for about 10% of humanity's greenhouse gas emissions, or carbon footprint. And so embodied carbon specifically relates to the greenhouse gas emissions associated with the manufacturing of materials. So from the extraction of raw materials to the construction of buildings. And it generally represents today about 30% of the carbon footprint of the building. But over time, that is expected to increase because of the technological improvements we expect in the operation.
So, for example, if this building that we're sitting in were run fully on solar energy, it would be effectively 100% of the equivalent emissions would be coming from the materials and construction process itself.
Exactly. So it would be a net zero operational building, but not a net zero life cycle building. Because if you consider those greenhouse gas emissions associated with manufacturing, those are quite significant. I think it's important that we really question these claims, because in the presence of such complexity, I mean, we're unpacking it now, but in the presence of such complexity, greenwashing is rife in the industry. So you may hear of a net zero building, a net zero project, but if you really just scratch the surface and look at what is meant by net zero, they often refer to the operation of the building. They've put a bunch of solar panels. And indeed, electricity use now is, there are no greenhouse gas emissions associated with electricity use, but what about the electricity, the energy, the diesel, the oil, all of the carbon-intensive processes that are required to manufacture these projects to begin with? Those are often put to the side. But there is a growing awareness and understanding where it's getting harder and harder to greenwash. And really to use these big words, but just apply to the operation and use of buildings.
Got it. I gave maybe 20 years ago in my thermodynamics course, I used to give an example of computing, say, the equivalent fuel used to make a so-called green building against a traditional building, one that uses solar cells. And if you account for the manufacturing of the solar arrays at that time, and so on and so forth, it turned out that the green building was actually a much bigger contributor to greenhouse gas emissions.
Yes.
Now, that I'm not saying that that's the case generally, and I'm also not saying that we shouldn't be continuing to make progress on solar, wind, and other forms of renewable energy. But I think your work is really highlighting that we have to go well beyond that and think also about how we make things.
Yes.
What about what happens when we dismantle things? I mean, ideally, we teach our students systems thinking and thinking about a circular economy rather than a linear economy. What goes on when it's near the end, when a building is coming down? What determines when a building comes down? Does a building have an expiry date like our milk? What goes on there?
That's a good question. I mean, it really depends on what you mean by a building, because you might dismantle every single structural element, every single component and assembly, but by replacing it with equivalent materials, is the building still there? Is it the same?
Sounds like an ancient Greek.
Totally.
Okay.
Exactly. But really what determines it is probably its structural health over time and the relationship that users have with the building. And that's often an argument that is used by proponents of design excellence and flamboyant buildings, and that they argue that beautiful buildings are more valued, and therefore, if they are more valued, they are more taken care of, and they have a longer durability, and we take care of them a bit more. But even in that, there are trade-offs, because to create such beautiful buildings requires, in most cases, more materials, and therefore a larger carbon footprint in the construction of those buildings. So, we're investing more carbon today in order to save more carbon decades into the future, when deconstruction and decommissioning techniques, we don't really know what in 100 years what the demolition of buildings looks like, which is why I'm a proponent of focusing a bit more on today and what we have in front of us, because again, these emissions will have lasting effects over thousands of years. But we should definitely take care of our built environment and strive to prolong their life. And one way of doing that is to really think about how to make buildings more adaptable to changing uses. So buildings are usually designed with a design working life of around 75 to 100 years. What will society look like in 100 years? Or say it's a building on the AUB campus, what will the student experience look like in 75 or 100 years? Will we still be running lectures and lab work, or will we be more relying on perhaps virtual work? And so these are all questions that designers need to contend with. But one way in which we can do the right thing when it comes to durability is to make sure that buildings can be adaptively reused. To think
because
about
the cheapest. I mean, you've given us a graphic in the past I've seen where you were talking about the like how much we have to go to achieve
yes.
global climate goals, and you've shown us that there's a certain percentage. The biggest saving is not building at all.
Yes, exactly.
And so this goes to, I think you're speaking to that point where
Yes.
If you can design your building to be flexible in its use, you may avoid having to reconstruct something else.
Exactly.
No matter what you do, that's always going to be the.
And you can also design it keeping disassembly in mind. There's a growing design school called Design for Disassembly that is being adopted and being taught, increasingly so in curriculum. That looks at the type of connections, for example, that we use in buildings, relying less on adhesives, more on mechanical connections, so that when the point comes, and it will come, to really think about that deconstruction and the reuse of those building elements. We need to move beyond an extractive model.
Can you say what you mean by extractive?
We essentially look to the living environment. Speaking of the built environment, we look to the living environment and we extract materials and resources from it to build those buildings. So one way to think about it is every time you build a building, you're digging a hole somewhere else, which makes that split between the built environment and the living environment a fictional split. They are very much related. We rely on those places. The Australian philosopher and environmentalist Val Plumwood refers to those places as the shadow places. We rely on them for our materials and our processes, but we neglect them in our understanding of them and our really empathy for them. So they carry the burden of our life in cities and in buildings. So we extract the iron ore to manufacture the steel. We extract limestone and a bunch of different materials to manufacture our cement. So that's what I mean by extractive. And so one way we can change that is to really see our cities as urban mines. Instead of going out to the living environment and then getting virgin materials and extracting them, we can start to view our buildings and our cities as an urban mine, where at some point those materials need to exit the current system they are in, whether it be a building or a pavement, so that instead of those materials going to a landfill, they could be used as materials for other buildings and other infrastructure projects. So there's a growing movement of urban metabolism and urban mining, which is trying to bring biological concepts such as the human body and its processing of waste, to really think about how we can think of our cities as living, breathing cities that have those same metabolic processes in order to move beyond an extractive built environment to a more circular one.
Fascinating. You've talked in the past also about the importance of not constraining or not limiting our thinking to the technical and technological.
Yes.
In a school of engineering, we're biased to thinking through problems as if we just develop this new technology,
Yes.
we'll be able to solve it. What's your perspective on that from having looked at the way buildings and cities metabolize
Sure.
the natural environment?
We're currently far exceeding our safe operating space on a planetary level. Our global greenhouse gas emissions are astronomical compared to where we should be. We've done some modeling showing that a 92% reduction is needed in humanity's environmental footprint, and that extends down to every sector in the economy. So if we just apply that same number to construction and the built environment, we need to improve our processes and reduce our carbon footprint by 92%. No amount of technological innovation will get us to that point, especially when you look at how historically efforts to improve efficiency have been counterproductive. Even if you look at televisions, for example, there's been a lot of work that shows that per inch, our electricity usage per inch has decreased quite significantly.
So you're talking about the size of the screen.
Exactly. So efficiency measures are often per square meter, for example, in a building, or per inch of a size of a television. So that we have achieved a lot of efficiencies there. So that number decreases over time, but the size of televisions over time has increased significantly. The number of households with televisions has increased. The number of televisions per household has increased, which has led to an exponential growth in our electricity usage, and therefore greenhouse gas emissions associated with our use of TVs, despite efficiency improvements. So in other words, efficiency is not sufficient. We really need to be thinking about sufficiency-led design.
Let's push this example even further. You've highlighted the chase, the arms race for taller and taller buildings. Who gets the claim on having the tallest building?
Yes.
And in that same paper I mentioned earlier, you calculated that in, say, Burj Khalifa or one of the taller buildings, I don't remember which one, just what's called vanity architecture or non-functional architecture that's added to the top of the building that no one can actually use adds a considerable amount of the total embodied carbon of that building. Can you say a little bit more about that? I mean,
Sure.
what first of all, what is vanity architecture,
Sure.
and then what's its impact, and why does it have such a big impact?
Sure.
I mean, those extra meters of height added something like 15% to that building. So
Indeed, yeah.
that seems shocking.
Yes, yeah. I mean, it's part of a growing list of studies I'm doing that explores the environmental effects of architectural design decisions. I find myself becoming more of an architecture critique from an environmental perspective, where I look at the built environment and I see design trends and I wonder what was the environmental impact related to that decision. And one of the most quite silly architectural practices, I think, is the use of decorative spires on top of tall buildings. These are usually these steel trusses. Sometimes they are cladded as well to create the perception of continuity in tall buildings that serve no functional purpose. They are purely decorative. And as you mentioned, with Burj Khalifa, that being currently the tallest building in the world, people are always shocked when they hear that approximately 30% of its height is purely aesthetic. It serves no functional purpose. It's just there for show. Approximately 4,000 tons of steel. That's beside the aluminium glazing, the glass itself, to create that continuity. It's quite an architectural design practice that you can see everywhere, literally in every skyline in every city in the world. And we were quite interested in understanding, well, what is the environmental effects associated with this design practice? So we did a very simple experiment in which we took a bunch of buildings and we designed them with and without these decorative spires. And in our modeling, we were very conservative in the decorative spire that we adopted. We didn't put a 30% vanity height spire on top of these models. We halved it. We just went with 15% and demonstrated that these spires have quite an adverse effect on the structural systems. They increase the wind loads that these structural systems experience. So therefore, you need a lot more steel and concrete to resist those forces, thereby increasing the material footprint and the carbon footprint of the structural system by 15%, as you quoted. So there's a significant environmental effect associated with this architectural design practice that serves no functional purpose. And so just to be specific, when I mentioned vanity height, I mean the height of the building above the highest occupied floor that serves no functional purpose. So this is not an antenna or anything like that. It's just purely for show. So the global arbiter for tall buildings, the Guinness Book of Records, if you will, for tall buildings, is called the Council on Tall Buildings and Urban Habitats, CTBUH. Every year they publish the list of the world's tallest buildings, broken down by city, by function, by continent, you name it. There's an award for everything. And the way that the building height is measured includes those decorative spires. So that's the equivalent of measuring our height while having pointy hats placed on top and saying, well, this is how much
This is how tall I am.
Exactly. So that creates an incentive for designers and developers to just put these pointy hats on top of their tall buildings and claim the tallest building on that street, in that city, in that neighborhood. And there are significant financial returns for being on top of that list. So there's these designers and developers are valuing prestige, the resemblance of power, if you will, as well as financial gain over environmental stewardship, social responsibility, leading to significant environmental effects. So it's an area of research that is of interest of mine, so that hopefully one day we can change how tall buildings are measured and ranked, so that it doesn't include the pointy hats and that it just goes to the highest occupied floor, for example.
There was another shocking number, I think, that you gave us before. Dubai's vanity height alone, so all of the vanity height in Dubai, it adds up to the yearly emissions of 15,000 people. Mm-hmm. And that's stunning.
But the reason why we singled out Dubai was because vanity height is most prevalent in Dubai. So we only looked at the tallest 100 buildings, and we literally just calculated the height of all of these pointy hats and found that the embodied carbon cost of those decorative elements adds up to the equivalent of 15,000 people, their annual carbon emissions. But if we were to relate it to the built environment, that number, we could have built around 2,500 average Australian homes, which again are the largest average home in the world. Perhaps if applied to the Lebanese context, I'd expect this number to be around 4,000 homes. And that's quite a shocking number when you think about not just the unfolding climate crisis and the limited carbon budget we have, but also if you think about the issues we have when it comes to housing affordability. We could have built 4,000 homes instead of decorate 100 buildings in this race, which raises the question of to what end?
If we were going to do things differently, tell me a little bit about how would that work?
An integrative design offers the opportunity to do so. And all it means is the bringing together of different disciplines as early on in the design process, so that all of those processes you talked about can happen in sync and not in sequence. And so perhaps a structural engineer might be able to raised some concerns very early on when an architect or developer proposes the addition of a decorative spire to say, well, hang on, if we were to do that, these are the implications, and hopefully influence the design decision. But it's not limited to engineers and architects and developers, because I think you once told me that no one discipline owns this problem. This is cultural, social. We need to involve building users, perhaps local politicians, bringing together as many people as we can. We've tried to do that a lot in the approach that we've been conducting. It's been mainly the integration of environmental assessment, structural engineering, and architecture put together, but we can push it way, way beyond that. And I think this systemic problem, in the absence of such an approach, requires a systemic solution. And I think the only solution to that begins with education. There's the siloing of disciplines in universities, which also occurs in industry. Not enough collaboration and co-teaching is being done between architecture, engineering, urban planning, urban design. We need to be putting our students together in design studios from their first year, where sure, you're an engineer and there's an element of specialization, let's say, in a higher education, but that doesn't involve working alone. And from the start, you're going to be working with landscape architects and urban planners and urban designers and construction managers, and perhaps someone from the liberal fine arts department, and really seeing how we can work together. So I think part of the solution to all of these problems is to work together through integrative design.
Let's double click on that too.
Sure.
Currently, in our curricula, whether it be in the civil engineering department or mechanical or in architecture, does anyone actually compute the embodied carbon in the design? Does it show up as a homework problem? Or is this something that is a meta question that you have to zoom out to ask in the first place?
I'd say traditionally, no, it hasn't been part of the toolkit of a typical engineering or architecture education, but increasingly it is being now adopted. We're seeing it, of course, at the University of Melbourne. I know that AUB is interested in this work, and we've done a bit of work together on mapping the curriculum and identifying places in which embodied carbon and life cycle assessment could be integrated in all courses. But it's not being done enough, I'd say. And more so, I think that if we were to begin teaching environmental assessment, to really dig deep into it, because method matters when it comes to these techniques. And since it is an emerging field that's actually not that regulated as well, there are a lot of shady practices as well. So we need our graduates to not only be competent with the existing methods that are being used in industry, but to really understand the underlying assumptions and data sources, because they are quite complex. And I think we should go into the complexity if we have a bit of time. So if you think about the embodied carbon, let's say, of a kilogram of steel, let's for a second imagine how would that be calculated. So how do you determine the total amount of emissions associated with just 1 kilogram of steel? Surely it would involve mapping out the manufacturing process step by step throughout the supply chain, and then trying to attribute a certain amount of energy and therefore greenhouse gas emissions associated with every step, and then adding them together. And that's what's happening in industry everywhere. It's called a bottom-up process approach, because you map out the process and from the bottom up you add it together. But who's calculating the greenhouse gas emissions associated with the rubber of the tire of the mining truck that is used to extract the iron ore from the open pit mine? No one, because these supply chains are infinitely complex. And while it may be reasonable for us to assume that, okay, that's just equal to zero, it's insignificant, if we make that assumption millions of times, because there are millions of examples that we can talk about right now, even sticking with the wheel, we can talk about the bolts and the spokes and all of that. then the cumulative contribution is not insignificant at all. And in fact, we've done some research demonstrating that it could add up to 80% of the embodied carbon of that kilogram of steel. So we need our students to not just take that document that's often produced by a third-party life cycle assessment consultant, but hired by the steel manufacturer to say that this is the embodied carbon of your product. We need students to look behind the numbers and really question, well, how can we ensure transparency, comprehensiveness, to allow us to use these metrics for comparative purposes. We're trying to work on state-of-the-art life cycle assessment methodologies that try to address these issues, but I'm afraid that industry hasn't adopted it to the full extent that it should, and universities as well are not teaching this content to the full extent that they should as well.
How can we incentivize companies to do the right thing? And is there a lower hanging fruit even before there? So, I mean, Amory Lovins points out many opportunities for making money by doing good. For example, if you can design your building in such a manner that designs out the need for all mechanical systems, the capital costs would be lower, the embodied carbon would be lower, and actually the thermal comfort would be better, and the developer makes more money. Are we already exploiting those opportunities, and now we're at the next level where we need to be thinking also in terms of sufficiency rather than efficiency?
We really need to change what the market values and how it sees, for example, smaller homes compared to larger homes. There are a range of mechanisms that are being explored globally, some being a carrot approach and some being a stick approach. With the stick approach, for example, countries around the world are beginning to explore a carbon tax. So in order for that cost premium to automatically, or the carbon premium to automatically become a cost premium, where that win-win is built into the financial instruments that we use. Countries around the world are also beginning to explore a tax on virgin materials. It's very cheap at the moment to manufacture, let's say, aluminium, as opposed to going to a demolition site, extracting it, and then recycling and reusing it. But if we change the financial dynamics a bit in that we can make virgin aluminium a bit more expensive, then perhaps that changes the game, and then suddenly the extraction of aluminium becomes a bit cheaper. So those are some of the fiscal financial tools that are at hand. But I really think that even with that, that's not enough. So to go back to that example we were talking about earlier with the Australian average sized home, one of the reasons why the size of an Australian home has doubled from the 60s till today is because these assets are being used for investment purposes. For wealth generation. It's very typical for friends, colleagues in Australia to try to save as much money as they can, buy a house, wait about 5 to 10 years, often doubling in price, and then selling it off, taking that extra money, and then going to the next real estate opportunity. And that has created this exploitative practice in which we are building larger homes, because if we can have a larger home, it means we can sell it for a bit more, so it has more financial gain. So those technological advancements, even those fiscal policies that we were talking about, the stick and carrot approach, these are insufficient to really change the culture and our relationship with homes. We can try to through taxation. We can have an additional tax on investment properties, perhaps a compounding interest bracket where for every additional investment property, you'd have to pay more taxes, which doesn't exist, by the way, in countries like Australia's. So we can certainly do that, but I think the starting point should be education. We really need to be shaping the next generation of built environment professionals, from engineers to architects, construction managers, to question these practices and to change how they view the built environment and the relationship that we have with the built environment. And hopefully over time, those new ideas can spread out into organizations, local governments, state governments, federal governments, because I think that's the only way in which systemic, sustainable change could be achieved over time with social, cultural changes, which is only possible through education.
So I guess there's a couple of things here that I want to react to. One is, I can imagine a group of professionals that have been trained in this way of thinking, pushing their clients, pushing their companies that they're employed in to ask these larger questions. Do we really need, can we encourage the client to stick with smaller buildings, for example, smaller houses, and point out that they can then even market it that way so that it becomes part of the culture, that you're living in a greenhouse. And again, raises the question of greenwashing and how greenwashing has been deployed, not always in good ways. But so that's one direction one could think of. Another would be thinking in the education system. And of course, this can't only be in higher ed. This has to be throughout.
Totally. Through parenting. Even.
Through parenting, even. You want to, your goal ultimately would be creating a culture that finds such excess obscene.
Yes, discouraged.
Discourages it one way or the other.
Yes.
And so that's the role of culture workers here.
Definitely.
So is the literature department at AUB part responsible for assuring that all the students that graduate from here have a critical sense on what greenwashing means and what does it mean to have a larger home? And should we be questioning that kind of model in the first place? And I'm saying that in a context where in Lebanon, there's not even a property tax on apartments. So, I mean, speculation is rife here. We have 30% of the of the apartments in downtown Beirut are vacant. Yeah.
Well, we could have a vacancy tax.
There's a housing crisis at the same time.
Exactly.
And that's because there's lots of empty apartments just owned for, as stores of wealth rather than as use value, having use value.
Yeah. And there are mechanisms around the world that we can look to. I mean, there are vacancy property taxes where if you don't rent out your apartment, you're subjected to a certain amount of tax. We do have the tools. We need the political will, essentially.
Which is fundamentally in a democratic society that's ultimately depends on people seeing things that way.
Yes. Yeah, and understanding that it is a problem to begin with before looking at the solution. And to go back to your first point, sure, the literature department has a role
the history
to play.
Department and philosophy, yeah. Sure.
And whereas we in the Maroun Semaan Faculty of Engineering and Architecture, we have a role to play in redefining what design excellence means, because there are architectural design features that are celebrated for their aesthetics, and you see it everywhere in architectural design magazines, in our lecture slides, perhaps, that might be solutions or practices of the past that have no place, I think, in at least in our celebration of design.
In a world that we're recognizing that we're living beyond our means.
Exactly.
They don't have
Are
there any examples from AUB campus that you would point to?
Sure. So we talked earlier about vanity height. I think of vanity height as one design characteristic of a whole range of design features that could be titled vanity architecture. For example, the use of cantilevers is one, and the Zaha Hadid design building, the Issam Faris Institute, widely celebrated and regarded as an example of architectural design excellence, is probably one of the most inefficient buildings of its height in the region, let alone in Lebanon. We've done some modeling on the embodied carbon effects and premiums of cantilevers, and we've done some preliminary modeling on the Issam Faris building, demonstrating that the effect could be as high as an additional 30% to the carbon footprint of the building just by cantilevering that segment of the building. And just to be a bit more specific, we mean that part of the building that is extruded, that is freestanding, unsupported by a column, which works against nature. And all you need to do to appreciate, I think, the inefficiency of such a system is just to hold out your arm a bit and cantilever it and just wait for about 5 minutes and realize the strain that is being added to your shoulder, for example. So to counteract that additional moment that we are creating, uh, hundreds, if not thousands, hundreds of tons, I would say, of concrete and steel were added to that structural system in order to counteract the increased bending moment. And if you read, the awards that everyone talks about the sustainability of that building, often referring to the ecological benefits of extruding a building and thus, um, you know, uh, not increasing the footprint of the building, thus preserving the local ecological footprint. But if you were to just walk around that building and look at what is beneath the cantilever, it's just concrete pavement. There isn't a habitat for an endangered species beneath it that might justify us not placing a column there. It's just a bunch of benches and some pavement. We could have easily put a column there, perhaps sacrificing on its aesthetics, but by doing so, reducing its carbon footprint by 30%. And yet, the Islam Faris Institute building is widely regarded as an excellent building in terms of its design. And the fact that AUB constructed it signals to its architecture students that this is an example of design excellence, whether it's communicated or not. It's quite subtle, but our built environment reflects our values. And so we need to push against, I think, these design trends, and also question what we mean by design excellence and move it towards something that is a bit more responsible and moral in an unfolding climate crisis.
You mentioned also that your building in Melbourne, the School of Design there,
Yes,
as beautiful as it is, also suffers the same problem.
Yes, the AUB is not unique in that sense. The building I usually work at is the Melbourne School of Design in the University of Melbourne, has a similar cantilever. My office is in that cantilever, so I go to work within vanity architecture every day. And I'd say this is also not unique to cantilevers. There is this interesting trend I find in universities and in their desire to have iconic buildings that places these universities on the map, thereby signaling design excellence and innovation and ambition, and as a way of attracting quality students and quality academics. But there's something quite hypocritical, I find, in that in our design and construction of these iconic buildings, we are putting aside our environmental stewardship and any sense of social equality and the responsible procurement and use of materials.
Do you use that as a teaching moment in your courses?
Definitely.
Say this is how building shouldn't be done?
Exactly, especially with the Melbourne School of Design, because in its design, there was a design competition at the time, and there were about 5 criteria that the building user, the university, specified as being critical for the design to achieve. One of them was built pedagogy, the use of the building as a teaching and learning tool. And I think originally the university thought of built pedagogy as just a demonstration, an example of design excellence. But over time, personally, I've been using that building as both an example of excellence design. There's great things about the building, but also as a counterexample. So what to do and what not to do. And I think that's a sign of a good educator and a good student, really, to look at examples around them and not just for the good that these examples have, but we can also learn from our mistakes.
Do you have a favorite building that embodies excellence in the way you would like to define it, or the way that you define it?
I don't think we need to look that far. I mean, I think you and I can now take a stroll around the AUB campus and identify some exemplary buildings. I think College Hall is a great one. As you walk through campus and you see those arches and those columns, it really is a great welcoming a building. To me, an example of architectural design excellence without the excessive pride and prestige and ambition that, for example, the Zaha Hadid designed Isam Faris building has.
I was waiting for you to say something about the wind load of the clock tower.
Yeah, so there are great examples, and often it is looking, I think, to the past. We're not the first generation of engineers and architects. This has been happening for thousands and thousands of years, and there's a lot to learn, I think, by looking at nature-based solutions, and also some of our earlier attempts when people were really thinking about limited resources. Especially in the absence of mechanization, they really needed to think of where does each stone go and where it should go. So I'd say we don't have to go far to identify exemplary architecture.
I see. One other concept that you and I have talked about in the past is burden shifting.
Yes.
Tell me a little bit about that in this context.
We cannot just design buildings as if they are these isolated systems. Buildings are located within neighborhoods and cities and require our infrastructure. More collaboration needs to be happening with urban designers and urban planners to make sure we're not shifting the burden from buildings to infrastructure, for example. So again, the solution to that would fall back to integrated design, the disciplines working together in sync, not in sequence.
Who bears the responsibility for making these large systemic changes that you're referring to today?
I mean, I think what you are touching on is climate justice, because there's no effective climate action if we don't address justice and the fairness of how we improve our processes and limit our greenhouse gas emissions. Just for context, the global north historically is responsible for about 92% of our excess emissions exceeding our planetary boundaries. So that's around 350 parts per million for CO2 concentration in the atmosphere. Today, we are at 422, so we are far exceeding our planetary boundaries. So if you take 350 just as the starting point, forget about what has happened before that, and if we just look at excess emissions, the global north is responsible for 92%. So the global south, so South America, Africa, the Middle East, we are responsible for 8% of those excess emissions. So what is a fair distribution of these efforts that are required to reduce the greenhouse gas emissions? If you look at our global agreements, such as the Paris Agreement, it doesn't adopt such an approach in distributing the responsibility. It looks at the population of every country, assuming that we are all equally responsible for the damage that has been done, and therefore we are all equally responsible for the changes that are required. And that's been how things have been going for the last.
So we're talking about 9 of the 10 slices of pizza have already been eaten, and now we want to divide up that last piece.
Yes.
And those who ate the 9 want to say, forget the fact that we ate those 9 already.
Exactly.
We're talking about the future here, not the past.
So this conversation is highly political, which goes back to what we were talking about earlier, that we need engineers to think and designers and professionals in the built environment to be able to have those conversations and advocate for a fair approach. And by the way, we're not talking about who is responsible for those emissions. So we're just talking about the emissions that are occurring in the global north and the global south. But just to make it even more political, Gaza will need to be rebuilt, and the south of Lebanon will need to be rebuilt, and the southern suburbs of Beirut and Bekaa and Yemen. If we were to rebuild those emissions would be accountable to us, and yet some could argue that we weren't responsible for the reconstruction efforts that are required. So even if we make it even less political and we just look at where the emissions are occurring, Historically, we are only responsible for 8%, and yet we are now required to have a much larger responsibility, especially considering that the global north only represents 17% of the world's population, yet it is responsible for 92% of the global excess.
Of the cumulative emissions, cumulative
Exactly.
excess emissions.
Exactly.
Yeah.
So we recently released a report focusing on the Australian housing sector. And we did a bit of modeling to demonstrate how much effort is required to achieve these changes. And we adopted the same approach that those international agreements adopted, in that we assigned a certain amount of responsibility to Australia that is proportional to its population. And so why did we do that? And the reason why we did that is industry would have not accepted attempts to reduce their carbon emissions if we were to make it a bit more political. So we really did it for practical, pragmatic reasons. We wanted this report to yield some action over time. We wanted to shock, but not to a state of paralysis. And so we adopted, I think, a more politically diplomatic, toned down version, which could be seen as a bit hypocritical, but we just wanted to get the ball rolling a bit. But over time, I would love to see more nuanced conversations around who bears the responsibility for reducing emissions, and not just between global north and global south, but perhaps across different sectors of an economy. Right now, we are considering that the built environment bears an equal share of the responsibility compared to its share of GDP across the different sectors. But perhaps there's a time when we should have a conversation, well, which sectors should bear that responsibility, with the built environment perhaps providing the means to meet a fundamental human right, which is shelter. Maybe other sectors of the economy can do a bit more, perhaps. So there's no right answer here. There's just complex conversations and difficult answers to reach.
Majd, I want to thank you for being with us today. It's always fascinating talking to you. I look forward to continuing this conversation in other venues and seeing how we can continue working together to make next generation education programs that address these complex issues and wicked problems. Thanks for being with us.
Thanks, Alan. It's a pleasure. Thank you.